Okay, this video here is going to be a recap of some sequence and series word problems, stuff that you should know how to do. I'm just going to walk you through the proper steps just to kind of tweak things and make sure any little mistakes that you're making get caught before our test. Okay, so I need you to follow along and play the game with the calculator. A diamond ring is purchased for $3,450. And it is appreciating. Okay, that means that the value is going up at a rate of 4%. The best thing to do with word problems is go ahead and make a list of the terms. Let's just turn this into a numbers game. So the first one is 3,450, and that would be our A1. And then the next year, since it's going up, what people like to do is take 3,450, they times by 0.04, which means it's going up by $138, which means the new value of the ring after you add on 3,450 is $3,588, and that would be A2. Okay, now you can continue this pattern times by 0.04. The next year it's going to be $3,731.52. And now I can kind of see what's going on. Okay, so is this arithmetic or geometric? So what you could do is take your two terms here. Okay, most people know it's geometric, and you take the second one and you divide by the previous one. And some people are still surprised that the R value is 1.04. Is the ring only worth 4% the next year? No, it's worth this entire amount plus an additional 4%, which is why the R value is 1.04. Okay, let's see. Write out the value for the first 4 years. Okay, so let's keep going and find A4. The next year would be $3,880.78. Write an explicit formula for the value of the ring. Okay, so A sub n formula is A1 times R to the power of n minus 1. For this ring, A1 is $3,450. The R is 1.04 to the power of n minus 1. Sometimes I like to split and flip this, but I don't know if that's going to get a little messy. I think I'm just going to leave it like that. Find the value in year 60. So they want me to use this formula to find the value of the ring in year 60. So let's go ahead and do our calculation there. 3,450, 1.04. 60 minus 1 is only going to be to the 59th power. And the ring is approximately, please play along and type it in. Okay, tell me what you got. It's going to be more, right? It's going up. Wow, it's actually worth a lot. $34,896 and good 84 cents. The value of the ring in year 60. Now, sometimes gems and gold will appreciate that quickly, sometimes not that quickly, but precious metals and gems definitely go up. Okay, let's review the bouncy ball. A bouncy ball can bounce up to 76% of its height. Remember, in mathematics, of means to multiply, okay, and 0.76 is how we'll calculate the percent. Let's see, it's dropped from a height of 12 feet. So at first, the ball is 12 feet high. It bounces against the ground, goes back up, and it's only going to bounce up to 0.76. So let's go ahead and do some calculations here. 12 times 0.76 means the height is only 9.12. Does that make sense that the bouncy ball is not going to come up as high? Okay, it's only bouncing up to about 3/4 of its height. And then it bounces again. Okay, and now it's up to times by 0.76, 6.9312 of its height. Okay, then it's going to bounce and come lower. So I kind of get the idea here. Okay, so it's definitely geometric. and the R is 0.76. Okay, let's see. I have to read the question carefully to see if I'm finding a term or sum. When I look at my diagram, A1 represents this first height, and A2 is the second height that it reaches, and A3 is this first height. So that's what the A's mean. The A's, the terms, are the heights after each bounce. So it says, what height does it bounce up to after it strikes the ground for the 5th time? So I'm just going to kind of look at my picture to make sure, because the number one mistake people make is they find the wrong term. This is the ball hitting the ground the first time. This is the ball hitting the ground the second time, the third time, the fourth time. Here's the 5th time it strikes the ground. It says after it strikes the ground for the 5th time, what height does it reach up to? So that's a height, that's a term, A1, A2, A3, A4, A5. So they actually want me to find A sub 6. Okay, let's do this. A sub 6 equals geometric. You start with A1, which is going to be a 12. Then you times by R, which is 0.76, and you raise it to the power of 5. So how high does it get? Go ahead and type it in. 12, 9, 6. I'm guessing something less than 6, right? 3.04 feet. That is the height it will reach to after it strikes the ground for the 5th time. Okay, so that's the answer to part A. Now part B here says, what is the total distance? What is the total distance this ball travels before it stops? So do they want the ball to bounce 10 times, 11 times? When it says total distance, it's a little more theoretical. Okay, so that means I'm going to let this ball bounce an infinite number of times. And it is possible to do geometric infinite if it's less than 1. It's convergent. This is going to work. Okay, so this is theoretical. I know gravity does stop it eventually, but we're going to do an S calculation. S is A1 over 1 minus R. So for this problem, A1 is 12. 1 minus R is 1 minus 0.76, and that equals to 50. So does the ball travel 50 feet? Well, not really. If I look at the diagram here, I added up all of the heights. I added up A1, I added up A2, A3, A4, A5, A6, forever. I added up all the heights forever. But the ball doesn't just keep dropping down, does it? Okay, remember how the ball bounces up and then goes down? So I need to take this infinite sum right here, and I need to multiply it by 2. So does the ball bounce for 100 feet? And the answer to that is no, because they all don't have ups. The first one didn't have an up, so then we're going to subtract 12, and we're going to get 88 feet. Okay, now what does 88 feet mean? Is that the S? That's not the S calculation. Okay, so I'm going to label this answer total distance. The total distance is 88. Don't label it S, and don't label this total distance. Remember, whenever you have total, you have to times by 2 and subtract A1, because the first one doesn't get an up. Okay. Another question that some people think is tricky are the trapezoids. So I'm going to kind of just go over all the tricky ones one more time. A trapezoidal design is made using 46 square pieces for the bottom row. So we have a really ugly trapezoid here. The bottom row has 46 pieces. Each row after that uses 2 less pieces. 2 less. So the row above that is only going to use 44. The row above that's only going to use 42. Okay, so this is definitely arithmetic. And the D is -2. Okay, less, 2 less. How many pieces are used for the 9th row? Okay, so that wants us to find a sub 9. A sub 9. Oh, first I should probably make a formula for a term. So I've got, let's see, 46 is the first term, 44 is the second, 42 dot dot dot, A1, A sub 2, A sub 3. The arithmetic explicit term is A1 plus n minus 1 times the d, which is a negative 2. Don't forget the parentheses. Then we'll go ahead and clean it up. Distribute, negative 2n plus 2 plus 48. So here is the formula for a term, and they want us to find the ninth one. So I'm going to do negative 2 times 9 plus 48. So a sub 9 is 30 tiles. 30 tiles. So dot dot dot, a sub 9 uses 30 tiles. Part B, how many pieces are used in all for these 9 rows? So they want me to add A1 all the way through A sub 9. They want me to find the total for these 9 rows. So does that sound like a term or a sum? That's a sum. That's S sub 9, and this is arithmetic. So the formula says n, which is 9. The first plus the last, 46 plus 30, all over 2. So the sum of these 9 is going to be how many tiles? Please play along. Okay, you, what did you get? No, I called on you. 342 tiles. There's also ways to kind of check. I know that adding all these nice numbers is not going to be a decimal. I'm also noticing that they're all even numbers, so my answer is going to be even. So if you get something really crazy, you could go ahead and think and see if it's going to work out right. All right, let's review a couple more. Sometimes this one is tricky for people because it's very vague with the directions. There's not a lot to go on here. It says find the sum of the first 30 integer multiples of 4. The best thing I could recommend is writing out the numbers. Multiples, so that means 4 times 1, 4 times 2, 4 times 3. Okay, what's weird is I'm saying times, but is this arithmetic or geometric? Here's a sub 1, a sub 2, a sub 3, dot, dot, dot. It looks like, oh, times by 2? No, it's not times by 2. This is arithmetic, and the D is 4. Okay, find the sum of the first 30 integer multiples. So this is the first one. I need to go all the way to a sub 30, the 30th one. First thing I'll do is make a term formula. A sub n is A1 plus n minus 1 times the d, and the d is 4. So let's clean up the formula, and the formula says a sub n is just 4n. Now I'm going to use that to find a sub 30. The 30th term is 4 times 30, so it's simply 120. Okay, so I'm adding the numbers from 4 all the way up to 120. This is arithmetic, so let's do an S sub 30 calculation. First we put 30, then you put the first one, then you put the last one, all over 2. S sub 30 is... Oh, why don't you go ahead and do that? Okay, the sum of a series is 15,960. I'm going to write out a lot of formulas for this, just kind of put all my information down so I can study it. This is a sum. The first term is 14. Okay, so a sub 1 is 14. The common difference is 2. Okay, so that's telling me that this is arithmetic. It's arithmetic, and the d is 2. Okay, so that means I've got 14, and then the next one would be add to 16, and then 18, and then dot, dot, dot. Okay, so this is a sub 1. The best thing to do is make your sequence and then label it. Okay. Find the number of terms in this series. So this goes all the way up to, I don't know, I'm going to call it a sub n. Now I can go ahead and make an a sub n formula, so I'm going to do that. The best thing to do is just start making as many formulas as you can and things will start to click. A sub n is a1, and I know that for this sequence, plus n minus 1, and I know the d is 2. So I will clean this up and get 2n plus 12. Okay, so here's the first term, the second term, and the nth term is 2n plus 12. Okay, so I see the sequence very clearly. It's kind of abstract with the letters there. Find the number of terms in the series. So the only thing we haven't used yet is the sum. Okay, this is the sum of the series. So like I said, the best thing to do is to write out as many formulas as you can. I'm going to write down the sum, the arithmetic sum formula, when it stops, the finite one, s sub n. The formula is n times a1 plus a sub n all over 2. And I know I have to work with this formula because they told me the sum. Let's plug in as much as we can. Do you know s sub n? Yes, it's 15,960. Do we know n? Nope, I don't know n, so that's a variable. Do we know a sub 1? Yes, 14. Do we know a sub n? Not really. I have a formula for it, so that's what I'll plug in for a sub n. So if you don't have a number, you might have to plug in letters all over 2. Great, we only have one variable, and we will be able to solve for this. So let's go ahead and multiply both sides by 2. 31,920. And maybe what I'll do is clean up inside the parentheses here. 2n plus 26. I have to distribute an n. Oh, is this turning into a quadratic equation? 2n squared plus 26n. Well, if it's quadratic, I better move everybody over to one side, putting everything in descending order. Oh, I can solve a quadratic. In fact, I'm just going to use this calculator program we're all falling in love with here. Quad form. A is a 2. B is 26. C is negative 31,920. Oh, it looks like we got two answers. So we have n equals 120 or negative 133. So n is the number of terms. So it looks like there might be two answers here. There could be 120 terms, or the other answer, wait a minute, you can't have negative terms. All right, so that one's extraneous. We'll just throw that out. So this series must add up to 15,000, must have 120 terms. Okay, so let's go ahead and take a look at the last problem here, which is similar, but it's going to be geometric this time. And we're going to do the same thing. We're going to write out all the information, make as many formulas as we can. The sum of the series is this. Okay. The first term is negative 1. The common ratio is 2. So R is 2. That means it's geometric. Okay, so let's go ahead and make a couple of terms just so we have a sequence to study. Times by 2, we get negative 2, negative 4, dot, dot, dot. Here's a sub 1, here's a sub 2, here's a sub 3. Find the number of terms in the series. Okay, so it says find the number. That means it must be finite. If here's a sum, find the number of terms. So it goes dot, 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 all the way up to the last one, which I don't know. I'll call it a sub n. I'm going to have to make a formula a sub n for this geometric series. So a sub n equals a1 times the r to the power of n minus 1. So I'm going to go ahead and clean this up. Remember, you have to split and flip, so 2 gets the n power, and then it gets the negative 1 power, which makes a half, and a half times negative 1 is negative 1/2. Okay, splitting and flipping. You guys did great on the quiz with that. Negative 1/2 times 2 to the n. Okay, I see all the terms from a1 all the way up to a sub n. Okay, it says find the number of terms. They did tell us the sum, so I am going to have to use the sum formula. The geometric sum formula goes a sub 1 times 1 minus r to the n power all over 1 minus r. And let's plug in as much as we know. Do we know s sub n? Yep, the sum is negative 32,767. A sub 1 is negative 1. And then we have 1 minus r to the n. R is a 2 to the n power. All over 1 minus r, 1 minus 2. And we'll have to do some calculations here to find n. So let's go ahead and do 1 minus 2. That makes negative 1. Oh, negative 1 divided by negative 1. That's just going to cancel out. Let's write down the rest here. We've got 1 minus 2 to the n power. Can I subtract these? No, because 2 gets the n power, not the 1. So maybe what I'll do now is subtract 1 from both sides. The parentheses really aren't doing much anymore, so we can go ahead and subtract that. So now we have negative 32,768 equals negative 2 to the n. Is the negative getting the n power? Not really. No, there's no parentheses around it. It's just r to the n. So that minus sign, I can go ahead and divide both sides by negative, clear that out. And now there's two types of people in the world. Are you a logger or are you a guesser? We've done this quite a bit. And so what we need to do here is find the n power. And I want you to go ahead and find how many terms this has. Okay, and I do want you to write down this note. It will be a nice positive number. If you get a negative, you did something wrong. There can't be 16.5 terms. And there can't be negative terms. So 2 to some power comes out to that even number. Please find that for me. Thank you.